Hello, this is a continuation of the explanation of the exercise on multiple linear regression. So I just explained the use of method chaining to avoid creating a new variable. This is the exact same Jupyter Notebook, except that I added some more comments here. Actually, it started from the top. Okay, I added more comments. You saw this one before. And then I added some comments here. I haven't changed any of these Python codes. And this is the part where I almost stopped when I find out the use of the isNow method, and then it returns a new data frame. And then I use the sum method on a new data frame to find out how many counts we have on each of the columns. But we can do the exact same thing without creating a new data frame by using just one line. So see, this one line replaces this line plus this line. Okay, and then you don't need to think of a new name like this. And this is called method chaining, and it's going to be very useful. And afterwards, we are going to find out the correlation between each column in our data set. So basically, we want to find out which feature or features correlates most with our target, which is MEDV here. Okay, that's why we are doing this correlation matrix. Now, if you're not familiar with it, then you can just use any search engine. I'm using Bing here. You can use Google, or you may even try to use some ChatGPT tools to explain this thing to you. But I prefer you to use search engines. So as you can see, there's some explanation here, and it says pandas dataframe.core is used to find the pairwise correlation of all columns in the pandas data frame in Python. Any NaN, which means not a number, values are automatically excluded. Okay, so as you can see here, so you have a simple data frame. Okay, and then you just call the call methods on the data frame. Okay. Now, this one website that I quite recommend if you want to have some simpler explanations of Python code, which is called W3 Schools. So in pretending I'm going to search for these strings again, so you scroll down. Okay, this is the official explanation, which can be quite complicated. And then you can keep going down and you see this is from W3 Schools. You click it, and then you see the explanation is rather simple. Again, it creates a data frame, and then it tells you, gives you an example, and then asks you to try it yourself. If you click here, then a window will pop up, and then you can actually try it, and then you can change some of the code to see the effect here. Now, the nice thing about W3 Schools is that the explanation is very simple. One of the most important things you need to know about a method is the arguments. Okay, what the inputs are to that method, and what the outputs are to that method. So this explains the syntax in a very simple way. Okay, so this is syntax, and these are the inputs. Okay, these are the methods, and then you have some optional parameters here. Okay, and then the return value, you can see the return value is itself another data frame, a data frame object with the results. Okay, that's why you're sure that when after you run this, you get another data frame. How do we know it's data frame? Well, because across the top we have the column headers. Okay, on this side we have the indexes. Okay, so this is a data frame, and this is just visualization to show the pairwise correlations in a very nice looking diagram using Seaborn. Actually, this line is not necessary. Now, many of the students do not explain this too well. Okay, so what we are trying to do here is using the data frame of the pairwise correlation, which is this one, and we want to apply the ABS method on it. Okay, so now assuming that we want to understand it better, we can insert a cell above this one, and then we can try to copy this, and then you can try to run it, and you can see that after you run the ABS method on the my core data frame, it returns you another data frame which contains all the absolute values in the correlation matrix. So here in this corner you see the minus see here we have the minus 0.14, okay, at the bottom, and then you're just 0.14 here. Okay, so this just changes it to absolute value, and then this specifies, okay, I want to find the 3 largest values. Okay, but when I want to find the 3 largest value, I want to specify the column that contains the 3 largest value. Okay, so what is that column? Well, that column should be the MEDV. Okay, meaning that I want to find out the highest correlations, okay, with this column. Okay, so this is the output, the 3 columns, and then I want to these are the columns. Yes, the 3 rows that contains the largest values in this column MEDV, and then I want to print out the indexes, okay, which is of course MEDV itself, and then median income, and then average number of rooms. Okay, remember these lines are from one data frame. Okay, just that the screen is not wide enough. Okay, and then we print out the indexes, which corresponds to this row, and then we print out the values, okay, which corresponds to these rows. Now when we print out these rows, okay, so this means we want to print out all the rows. Okay, but there are only 3, so we are going to print out all 3 rows. But when we print out all the rows, we just want the 8th column, which is this one. That's why we get 1, which is 1 here, 0.088, which is this one here, and 0.015, which is the one here. And then moving on, this just plots the data points on a graph, which is very obvious. Okay, most of you inserted comments to explain the use of these statements, and this is very obvious. For example, this one, set the title to median income, and so on. So this is rather straightforward. Okay, and then we are almost near the end of this exercise. So here we create the feature data frame by combining columns of average rooms and median income in my DF. Now this is from the book, okay, and you got it from my slides, but this seems to be hard to understand. So if you want to know more, you can actually search for this. Okay, as you can see, NP is NumPy. How do we know it's NumPy? Because NP is the alias we gave to NumPy at the very beginning, at the very top. So if you want to understand this statement more, which is the purpose of this exercise, you can just search for it. Okay, you can search for it, and I've done some searching. Okay, and Actually, you may want to just search for something like numpy.c underscore. As you can see, it's quite a popular search. And then there are some explanations here. Okay, and this is the official explanation. Okay, so basically it says it can concatenate along the second axis. But if you do not quite understand it, that's okay. Because you see the word concatenation, you can actually search for an explanation of this one. And this is what I did. I go to a search engine, not this one, but I can do it right here. Okay, concatenating data frames. So frames, and you can find some explanations here. Okay, and then there's official documentation, and this is from Geek4Geeks, and then you have something from other places, and so this also there's one from W3 schools later on. So let's go to this one, the first choice. Okay, which says how to concatenate 2 or more Prentice data frames. And this is the suggested method. You create some data frames, and then you can concatenate them, okay, using the PD concat method. Okay, so you create some data frames, you call the PD concat method, you give the, a list. The list contains the data frames themselves as arguments, and this is concatenating along the rows. Okay, and this is concatenating them along the columns. This is vertical. Vertical means that you stack one of them over the other, so this is axis 0 to 0, and this one is horizontal, meaning joining them and make it a wider data frame. Okay, so in the end we have a new data frame in which 2 columns are combined horizontally, and then this gives it the column names. So if you print X here, you'll find out it's another data frame with only 2 columns and the same number of rows as before. Okay, so this is a feature data frame. Okay, it's not just a matrix, but it's a data frame. And then likewise, we use the medium value, which is the target, and create a series of the target, which is this one. And from then on, from this point onwards, it's rather straightforward. Okay, we just use our old friend train test split, okay, and pass it the X features data frame, which is the one right here, and then pass it the Y, which is the label series. Okay, we specify that we want 20% in the testing set, which means 80% in the training set. And as I said before, random state, you can assign any number as long as you keep it the same every time you run this Jupyter notebook, so that you can compare the results. And you may want to remind yourselves here, okay, train test split returns a tuple, which is unpacked into the variables such as xtrain, xtest, and so on. Okay, so after you have obtained these training sets, you can call the linear regression model. Okay, this line creates another object from this constructor, linear regression, and you can call it any name you want. This is not a good name because I call it SLR, okay, which stands for simple linear regression. Now the name itself actually does not matter. Okay, you can call it John or Mary, but it's better to use a more meaningful name because we are doing multiple linear regression. I would prefer to call it MLR. So you can do the edit, find and replace. You do SLR, and I want to replace it with MLR. Okay, and I want to replace all. And as you can see, it's now all replaced. And then you can run it and you get the result. Okay, thank you for watching. Bye bye.